Hi, everyone. I'm Avner.
I'm Adam.
And we want to talk to you about tooling in FaaS environment and continuous integration, continuous deployment. So we keep wandering the halls in Serverless conference and other conference and talking to people in Serverless, and they always complain. Everybody's like, where are the tools? We want tools. We need to do logging. We need to do monitoring. We need to do debugging. We need to do testing. We need tools. So just from scouting the booths outside, I think we have our best people working on it. But let's see if we can do something about it right now. So Binaris, our own company, is we're building our own FaaS platform. And in the process, we're building and deploying and testing and using a lot of functions. So a lot of functions internally. And one of the questions we ask ourselves is, can we use functions to build tools for functions? So can we use sort of self-reflecting tools that are built out of functions and are used help us in our own daily processes? And the answer naturally is yes, and we want to show you what we did. So we'll do it in two parts. The first part will be mostly a description of what we did and what we built and how we use the functions to build our own sort of test framework internally. And then we're going to ask ourselves, where can we take this? And where can that grow and help us kind of go towards more of a real CI/CD pipeline? So we start small. We start with word count, the kind of classic example. It's a cloud function, and let's see how it looks like. I think it's going to be here. Yes. Adam?
Thank you. So this is our function. We have the function signature on the first line. It declares a single variable called input that it is expected from the caller. We then declare an object called counts. This is the response object that we return to the caller with a map from a word to the number of occurrences it appeared in the input. So we have here like classic JavaScript code. We iterate over the word, which is in the input object. For each word, we increase the counter for that word into the counts object, and then we return counts. Note that we don't have any HTTP lingo in this function because we expect an object and we return an object. That is because the framework is responsible for serializing and deserializing all the data that comes in and out of the function. Let's see that in action. The following terminal was pre-recorded to avoid all the demo failures when you have not so very reliable internet connections from times to times. We deploy the function using our CLI, bndeploy_wc, which is word count. Note that we get two endpoints or two ways to invoke the function. The first is an HTTPS endpoint. We can call it with curl or with any HTTP package in the language of choice. And the second is just bninvoke_wc, which lets you just run it from the CLI without all the HTTP hustle. Let's see that. bninvoke, we send the function some data, an object with the key words, which points to an array with A once, B twice, and C 3 times. And we should expect to see exactly that, A1, let's run it. Exactly, A1, B2, and C 3 times.
Excellent. So that was word count. Fairly simple. Now, usually when we want to test such a function, there are different ways today to kind of run cloud functions locally. SLS has one, Azure has one, I think AWS has some method today. And that lets you kind of write your own unit test code, run your function locally, test it, make sure that it works, and then send it to the cloud. We took the opposite approach. We said, what if we took our unit test code and packed it in its own cloud function? So now we have a function that's actually doing something and a function that's testing that function. let's look at test. Let's look at that function and see how it looks like. Here it is. If I just find the cursor, should be somewhere. Something here is strange. Oh, okay. Here it is.
And here we go. Okay, this is the test function. It calls the word count function and reports whether it passed or failed. We begin by requiring the Binaris SDK in order to be able to invoke other functions. We could have done it with Node.js request or any other HTTP package, but it's shorter and easier that way. We then require Chai, which is a popular JavaScript testing framework. We define a list of words, I, love, and functions, which we'd like to get the count for. And we have the expected count on line 8. We expect to see I once, love twice, and functions thrice. Then there's the code that actually tests the word count function. We expect no input here, and we use Binaris invoke WC with the words as input. We use the ES7 await mechanism in order to wait until the deployment is completed before we assert the tests, and only when the invocation is done, we check using expect. We compare the counts that actually came from the Binaris invoke to the counts that were expected. And note that we don't return anything if the test passes. And if the test failed, we use the built-in throw mechanism. We throw an exception, and the framework behind the scenes converts it into an HTTP error code and message. Let's see that in action. OK, so we changed the directory to the test directory. And again, we deploy that function into the cloud. And this time, again, we get the endpoints that we expect. And when we invoke it without data. We just run it, and we get success equals true. The test passed.
Oh. Right. So we have a working function. We have a test function. Usually one test function is not really enough. We might want to have 3 test functions, maybe more. And this becomes a little bit cumbersome. Now if we want to update word count, add something, change something, fix something, we need to run all the tests, which means that we need to go to the CLI, manually deploy the function, manually run each and every test. That kind of gets uncomfortable. And that's also where we get our first tool. So we build another function, this gray one here on the right. It's called autotest. And this function is responsible basically for deploying a code to a function. It can be a new function. It can be an update to an existing function. And then run a list of tests. So basically, autotest gets as arguments the name of the function to deploy, the code for that function, and a list of names for test functions to run on that one function. That's going to be a little bit longer code, but let's see if we can get through this. Adam?
It's longer, but it's really cool. So let's take a look. We begin. This function is supposed to deploy a function to the cloud with new code, run all the tests in parallel, and return a list of failed tests for the function, or an empty list if nothing failed. So we begin by, again, requiring the Binaris API in order to be able to deploy and invoke functions. We then have a function that runs a single test. It's simply, you get the test name as an argument, and then it invokes that test, again, using ES7 await in order to wait for the invocation completion. If there's an error that is thrown from the test, we catch it and return the test name. And if no error is thrown, we return nothing, which is in JavaScript. Now, what we do here is that this function returns a test name if it failed and nothing if it worked. Now, this function is responsible for orchestrating the entire cycle. We get a single input object. We then deconstruct it to a function name, function code, and a list of tests. we take that function name and code, and we deploy the function. In this case, we deploy the word count function, which has been changed. And then we would like to run all the tests in parallel. So we map the list of tests we got as an input to the test1 function, meaning that we run the test1 function for each test name. We use the promise all mechanism in order to make sure that everything is done in parallel, and that we wait till the last test is finished before we get the response. And the response is a list of tests, either empty or the test name. And then we filter out the tests that were successful, and we only return an array of failed test name. So let's see that again in action.
This one.
Perfect. We have an auxiliary script in order to run that function. We have WC, which is the function name we're deploying. We have the function code, which is in a parent directory. And we have a list of tests, WC1, 2, and 3, which will be invoked testing the word count function, all in one line.
It's important to note that the script here is just a wrapper, basically around Binaris invoke, around our SDK. We just use it as a wrapper because extracting the content of a file in the command line and escaping it and sending it to the function is a little bit tedious, and we didn't want to have to do it in bash script here.
OK, as this run, we see that a test has failed, WC test 3. Let's take a look at the test and see why it failed. So
for some reason,
let's switch. Yeah.
Cursor gets lost when we switch.
OK, simple enough. We sent two words which are supposedly identical to the function, to the word count, apples with a capital A and apples in a lowercase. And apparently, our word count function is case sensitive.
I think we forgot to fix the case.
Oh, let's fix it.
Let's fix it. Let's go here and just convert everything to lowercase. Now, if we just run the script again, it will deploy and retest. Let's see how it looks like.
OK, so we run it again. Now we measure the time it takes to run that cycle. And nothing failed this time. And note that the entire process, rewriting a function, deploying a new code, and testing 3 tests in parallel, takes about 1 second.
That's this one here on the right. So about 1 second for the whole cycle. Thank you, Adam. So that was Autotest. Autotest encapsulates tests or unit tests inside Cloud Functions. It's a function-based tool, so the tool itself is built out of Cloud Functions. And it's just super fast. So we can use it in our development cycle without having to go make coffee every time we want to redeploy and retest our code. It's so fast that it can kind of blend into our development cycle and really create this edit, deploy, edit, deploy test cycle without the developer ever losing focus. So that's Autotest. Where do we want to take it from here? What's the next steps for us? So the first thing is that a function is usually never a whole application. So we started with word count at the epicenter of this demo application, but usually we want to do something more. And in our case, we can build a slightly bigger app, built out of multiple functions, to classify documents. So it could have multiple parser functions, one for HTML, one for PDF, and all those functions do is just take a document, strip off the control words and control characters, and just spew out a list of words. Word count would count them. And then we can feed those into a classifier that would, say, determine what type of content the document has, or what kind of mood the writer was in. So we could do different classification, different analysis there. Now, classify itself might have multiple unit tests of its own, but we might want to test the whole thing. And that would require a different type of test or a module test. So having all those different types of tests and being able to run them in parallel and run them sort of and control which ones run after which ones gives us more power in terms of testing our application. Once we have that, we can grow into a real CI/CD pipeline where we start off with unit tests, we go to module tests, and even full application tests. And once those pass, we can do canary deployments, greenfield deployments, and even full deployments for the entire user base. And the way such tool could be built really leverages two aspects of a function environment that are not common in other environments. One is the scale, is the ability to run all those tests in parallel, to parallelize across those multiple tests, to test multiple phases maybe together, maybe some module tests depend on unit tests, maybe they don't, so we can manage those independently. And the second thing is versioning, right? If we have the right versioning system, we can have multiple versions of the same function coexisting in the same time on our platform. So we can have some of them in development mode being tested, some of them in more advanced kind of application test mode, and some of them deployed to some users, and so on and so forth. So how this tool will look like and what types of those transitions will be automatic, which of those transitions will be automatic, which will be manual, is of course depending on the user and your use case, on your specific use case. And finally, we can do something nice with IDE integration. So since this is so fast, how about we just build it into an IDE? All IDEs today have plugins, so we can just have this sort of status bar at the bottom that says, as you're typing, as you're modifying your code, did it test well or did it fail? Which of my tests fail? And if they did, maybe pinpoint, show me where it failed in the code, or what edit did I made that made it fail. So this is something that we think has the potential to really change how we work with code and how fast we can build and modify and deliver new features. So just to recap, serverless is a new thing. Function is a new thing. Is a new way to build application. There's still a huge gap for FaaS tools. The good news is that we can use FaaS to quickly build tools for FaaS, and those tools have the potential to deliver a unique new developer experience. We can leverage the scale and inherent parallelism in a FaaS environment to do things that we couldn't do before. And we can leverage the speed, given that your platform is fast enough, and our platform is definitely focused on building as fast or invoking functions as fast as we can couple those two together to create completely new user experience or developer experience that were just never possible before. Being able to test as I code the functions is something that we believe has the potential to change the way people work. It changed how we work, and it can change how developers spew out features faster and faster. Thank you very much.